purpose of this video is to describe or determine the initial velocity of a thrown or launched object. As we can see from the motion maps, the velocity of the object at the beginning is u. As it travels upwards, it slows to a stop and then returns to the ground with the same velocity, only in the opposite direction. We can collect a variety of different data for this project. In this particular example, we are going to measure the amount of time in the air. If we create a graph of our situation, we can see that we have an initial height, S sub O, and we can measure our time. Some other things that we know are the acceleration of gravity, negative 9.8 meters per second squared, and the final height, S, which is 0. Using the basic equation for a parabola, y equals ax squared plus bx plus c, we can see that this applies to our physics in the terms of s equals 1/2 at squared plus ut plus s naught. Our goal is to measure the u in this equation. So therefore, we're going to solve for that u. Our constants are gravity of negative 9.8. We are going to assume that we are throwing it from a height of 1.5 meters, shoulder height on an average high schooler, and our landing point is going to be the ground, or 0 meters. If we plug in our 4.5 seconds, we can see that our u is the only term that is left. By combining the 1/2, the negative 9.8, and the 4.5 squared, we get negative 99.225. We combine that with a plus 0.5 and we get a 97.725 equals 4.5 u. We've moved that 99.225 to the other side, making it positive. We now simply divide both sides by the 4.5 and we get a u equal to 21.71 meters per second. Likewise, we can collect some data based on the height of the throw. Many of you did this with your iPhone 5s with the slow motion video and captured the maximum height. There are two ways of solving this. One is a two-step process and the other is a one-step process. We'll go through the two-step process to begin with. The first thing we want to do is determine the time. In order to do that, we're going to assume that our initial height is 1.2 meters, our final height is 4.5 meters, we have an acceleration of gravity of negative 9.8, and our maximum, or our velocity at the very top, is going to be 0 meters per second. By combining some like terms, we get negative 3.3 equals negative 4.9 t squared. Dividing both sides by the negative 4.9, we have t squared equals 0.67, and then t equals 0.82 seconds. This is the amount of time it takes to get from your hand to the maximum peak. We then take that time and place it into the v equals u plus at equation. Simply solve for the v. If we make the assumption that the velocity up equals the velocity down, then we can therefore say that the u is equal to 8.04 meters per second. This is a two-step process using two of the equations that we've already had. However, there is an easier one-step method, but it involves an equation we have yet to see. We will see this in about 2 weeks. Again, same scenario. However, we're going to redefine a couple of our terms. We're going to have an s of 4.5. We're going to have a maximum, or a velocity at the top of 0. We're going to have an initial height of 1.2. We're going to have a gravity of negative 9.8. And again, we want to find u. The equation that we would use is v squared equals u squared plus 2a delta s. The delta s is simply the change in height. In this case, our final velocity is going to be 0 at the very top. U squared is what we're looking for. If we now calculate 2 times negative 9.8 times the change in height, which is 3.3, 4.5 minus 1.2, we get a value of 64.68. That is a negative. We've moved it to the other side, so it's now 64.68 equals u squared. We find the square root of both, and we get a u of equaling 8.04 meters per second. And we can see that that is the same as our two-step method on the other side. Again, we are going to continue this equation in the future, associating it with energy. But here are two different ways of determining the height of the velocity of a thrown ball given the height.